Trig Lesson 2.3. This is getting us ready for the homework. You need to be reminded that a function has an inverse if it is 1-to-1. So let's talk about what a 1-to-1 function is. Each value of the y is associated with only one value of the x. It passes both the vertical and the horizontal line test. So this is a 1-to-1 function. This is not a 1-to-1 function. So we look at sine. This is the sine. And we say, oh, it's not 1-to-1. So we're going to have to restrict the domain. The original domain of the sine runs from negative infinity to positive infinity. Its range only runs from negative 1 to 1. So if we restrict the domain to negative pi over 2 and pi over 2, like I have sketched here, this section is 1-to-1. And it has an inverse indicated by sine inverse of x. So the whole sine function is not 1-to-1, but when we restrict the domain to negative pi over 2 and pi over 2, then we get a section that will have an inverse. The same story for cosine. By restricting the domain of cosine from 0 to pi, 0 to pi, that section right there, we can find inverse, and it's cosine inverse. And the same about the tangent, by restricting it from negative pi over 2 to pi over 2. Now remember, tangent is y over x, so tan inverse is x over y. Cosine is x over r, so cosine inverse is r over x. And sine is y over r, so sine inverse is r over y. So the two that have to deal with y on the bottom have the same domain. Just keep that in mind. Number 4, fill in the blank. The domain of sine inverse x is, now remember, sine has an inverse. You swap the domain in the range when you find its inverse. So if you restrict sine to that section, it will have an inverse. And the domain of sine inverse is going to be whatever the range was for sine. And the range for sine inverse is going to be whatever the domain was. So they just swap. Same thing for cosine. Cosine has an inverse. The cosine has a domain from 0 to pi and a range from negative 1 to 1. So cosine inverse has a domain negative 1 to 1 and a range from 0 to pi. Number 6, tan has an inverse. Tan domain is negative pi over 2 to pi over 2. Tan inverse will have a domain from negative infinity to positive infinity. So it's tied to the range, and the range is from negative pi over 2 to pi over 2. Fill in the blank so the resulting statement is true. Sine inverse of sine is equal to x for every x in the interval from negative pi over 2 to pi over 2. It's its domain. Fill in the blank. Cosine inverse of cosine x is equal to x for every x in the interval from 0 to pi. And tan inverse x is of tan x equals x for every x in its interval. And what these are the domains for your inverses. Determine the following statement is true or false. Cosine inverse x equals 1 over cosine x. That's false. 1 over cosine is equal to the secant, and this is not the same. Determine the following. This y equals secant inverse x. The domain of that is negative infinity to positive infinity. Secant x has a domain and a range. So the domain here is negative infinity to negative 1 in union with 1 to infinity. And that takes care of 2.3.